Hello everybody, so today I'm going to talk to you about Sankey diagrams. Now a Sankey diagram is a diagram that we use to show the energy changes that take place in a device. An example that I've drawn up here is looking at a car engine. So a car engine, if you start at the left hand side, will take in 1000 joules of chemical energy from the petrol. And as we follow the diagram along to the right hand side, we'll see it branches off into two separate paths. The part that goes straight ahead is the useful energy. So for a car engine, 200 joules of energy will be transferred into useful kinetic energy. If we look at the part that slopes downwards, there's 800 joules of energy. This part is the wasted energy, and in a car engine this is going to be heat. What's really important to remember is that the total energy out should be equal to the total energy in, because this ties back to our law of conservation of energy. The energy can't be created or destroyed, only transferred from one form to another. So our chemical energy here is transferred into kinetic energy out and heat energy out. Again, the total amount afterwards adds up to 1000 joules because that was the total amount put into the system. Okay, so now we'll look at an example of a question. So in this question here, we're talking about a light bulb. We've been told there's 50 joules of electrical energy going in and 30 joules of useful light energy out. Now what's important here is that these don't add up. So we're going to look at how we can tackle a question like this. So we'll first start drawing what we do know. We'll draw our Sankey diagram. We're going to label the 50 joules of energy in. We've been told that there's 30 joules of useful energy coming out. So we're going to take slightly more than half of this. We're going to make sure that goes straight ahead there. So there's our 30 joules of useful light energy. Now, because of the law of conservation of energy, we know that the energy in must equal the energy out. So we're missing 20 joules of energy here to make up the 50 joules of energy that we're putting. So what that means is that we have to make up an extra 20 joules of energy. Now, because it's a light bulb, we can guess that the extra energy that's being wasted is going to be wasted as heat. Anybody knows this who's ever burnt their finger by touching a light bulb? They get very, very hot. So we have 20 joules of wasted heat energy. So whenever you're looking at a question, I would just, once you've done your diagram, come back and look at an example like this that you've taken down, making sure that you have the different amounts of energy labelled. You've labelled what type of energy it is, electrical, light, heat, and you've said for the energy output whether it's useful or wasted.